Hello, welcome to part 14. Yeah, this is the last thing I did, and let's go to the measurements. Pre-algebra. Whoa, okay. Wait, what? Ah, yeah, of course. I actually did this. Is actually the last thing I did. First quiz, and then this is where I left off. Whew, okay, cool. Let's go. Perimeter deduction. Okay.
When people use the word perimeter in everyday language, they're talking about the boundary of some area. And when we talk about perimeter in math, we're talking about a related.
But of course, am I recording? Okay, we're recording. Cool. And let's see if
Idea. But now we're not just talking about the boundary, we're actually talking about the length of the boundary. When people use the word perimeter in everyday language, they're talking about the boundary of some area. And when we talk about perimeter in math, we're talking about a related idea. But now we're not just talking about the boundary, we're actually talking about the length of the boundary. How far do you have to go around the boundary to essentially go completely around the figure, completely go around the area? So let's look at this first triangle right over here. It has 3 sides, that's why it's a triangle. So what's its perimeter? Well, here all the sides are the same. So the perimeter for this triangle is going to be 4 plus 4 plus 4, and whatever units this is. If this is 4 feet, 4 feet, and 4 feet, then it would be 4 feet plus 4 feet plus 4 feet is equal to 12 feet. Now I encourage you to now pause the video and figure out the perimeters of these 3 figures.
Oh man.
Well, it's the exact same idea. We would just add the lengths of the sides. So let's say that these distances, let's say they're in meters. So let's say that this is 3 meters, and this is also 3 meters. This is a rectangle here. So this is 5 meters. This is also 5 meters. So what is the perimeter of this rectangle going to be? What is the distance around the rectangle that bounds this area? Well, it's going to be 3 plus 5 plus 3 plus 5, which is equal to, let's see, that's 3 plus 3 is 6, plus 5 plus 5 is 10. So that is equal to 16. And if we're saying these are all in meters, then it's going to be 16 meters. Now what about this pentagon? Let's say that each of these sides are 2, and I'll make up a unit here. Let's say they're 2 GNUs. 2 GNUs. That's a new unit a new unit of distance that I have just invented. 2 GNUs. 2 GNUs. So what is the perimeter of this pentagon in GNUs? Well, it's 2 plus 2 plus 2 plus 2 plus 2 GNUs. Or we're essentially taking 1, 2, 3, 4, 5 GNUs, 5 sides, each have a length of 2 GNUs. So the perimeter here, we could add 2 repeatedly, 5 times, or you could just say this is 5 times 2 GNUs, which is equal to 10 GNUs, where a GNU is a completely made up unit of length that I just made up. Here we have a more irregular polygon, but same exact idea.
19.
How would you figure out its perimeter? Well, you just add up the lengths of its sides. And here I'll just do it unitless. I'll just assume that this is some generic units. And here the perimeter will be 1 plus 4 plus 2 plus 2. Let me scroll over to the right a little bit. Plus 4 plus 6. So what is this going to be equal to? 1 plus 4 is 5. Plus 2 is 7, plus 2 is 9, plus 4 is 13, plus 6 is 19. So this figure has a perimeter of 19 in whatever units these distances are actually given. What is the perimeter of the shape? Each square in the grid is a 1 by 1 centimeter square. So all we have to do is add up the lengths of these blue segments right over here, and they put it on this nice grid, and each box here is 1 by 1. So we could, let's say we start up here, and we want to make sure that we only go to where we started and we don't double count. So this perimeter is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21,
Wow.
22,
Okay,
23,
cool.
24
Actually,
centimeters
correct.
long.
Cool.
So it is 24 centimeters. The other way we could have thought about this is you could have looked at the length of each of these sides. So this is 1 plus 2 plus 3 plus 1 plus 3 plus 1 plus, what is this, 5 plus 2 plus 4 plus 2. And you would have also gotten 24 centimeters. Let's do a couple more of these. What is the perimeter of the square? So once again, it's the length of all of the segments that define the outside boundary of the square. And by definition, a square, all of its sides are equal. So you have 4 sides that are all 7 meters long. So you could say it's 7 meters plus 7 meters plus 7 meters plus 7 meters. Or it's 4 times 7 meters, or 28 meters. 28 meters. Let's do one more. What is the perimeter of the
10.
regular pentagon? So it's a regular pentagon, which means all of its sides have the same length, and they give us the side of 1. The length of 1 is 2, so all of the sides have length 2. So it's going to be 2 plus 2 plus 2 plus 2 plus 2, or essentially 5 2s. Or another way of thinking about it is it's 5 times 2, which is going to be 10. You have 5 sides of this pentagon. Each of those sides are 2 units long. So 2 units long times 5 sides is going to be 10 units.
What is the perimeter of the figure below? So down here we have this figure, and we are asked to find the perimeter of this figure.
25.
Perimeter is the distance all the way
Oh, wait,
around the
it's actually-
outside of a shape. So
Okay,
in this case, if I were to
25,
walk
32, right?
around the outside, or maybe a human's too big, if an awesome little ant was to walk all the way around the outside of this figure,
32
how far she
centimeters.
walked would be the perimeter. So to find that, what we can do is figure out how long is this side, and then combine it with the length of this side, and combine it with the length of this side. And once we combine all of the side lengths, we'll have the perimeter, or the distance around the outside of the figure. So let's start. We can start up here. We can see that this side length is 5 centimeters. So we have 5 centimeters. Plus, moving down the side here, we have another 3 centimeters. And then going across, next distance is 4 centimeters. After that, we go down this side right here, which is another 4 centimeters. And as we keep going across the bottom, we have another 9 centimeters. And then we head up this side, and we don't have a label. We don't know how far this is. But to find
7
perimeter, we need the
centimeters,
distance
yo.
around the entire outside. If this little ant, she walked the whole way, we've got to know the entire distance she walked. So what we can do is, we can look over here and say if this length right here is 3 centimeters, well then that same length over here is also 3 centimeters. And where that 3 centimeters left off, this 4 centimeters, this length picked up. So from here to here is another 4 centimeters. So if we have 4 centimeters plus another 3 centimeters, that's a total of 7 more centimeters. So now we know the entire, all of the lengths around the outside. So if we combine them or add them, we'll know the perimeter. So we can start 5 plus 3 is 8. 4 plus 4 is another 8. 9 plus 7, let's see, instead of 7, I could do 9 plus 1 and 6, because that's the same as 7. 9 plus 1 is 10, and 10 plus 6 is 16. 8 plus 8 is another 16, so we have a 16 and a 16. 16, let's see, 6 ones plus 6 more ones is 12 ones. And 1 10 plus another 10, or 10 plus 10 is 20. So another way we could add this is 20 plus 12, which is a total of 32. And we were talking about centimeters here, so 32 centimeters. The distance all the way around the outside of this figure, or the perimeter of the figure, is 32 centimeters.
The distance to the ant wall.
The perimeter of the figure is 24 centimeters. What is the length of the missing side? So we're told this figure down here has a perimeter of 24 centimeters. The perimeter is 24 centimeters. So what that tells us is that the distance around the entire outside is 24 centimeters. But what we want to know is what is the length of the missing side? Well, the missing side is going to be the side we're not told, so it will be this one here because we have this question mark. It's missing, right? It is not labeled. So we've got to figure out what number should go on this missing side so that the entire length is 24 centimeters. So let's start with what we do know. We know that this top length, this top side has a length of 6 centimeters. Plus, going down the left has a length of 5 more centimeters. Plus, across the bottom is 4 more centimeters. And the last known side is another 4 centimeters. So when we add all those plus this mystery side, we should get a perimeter of 24. The entire distance, all of this, the 6 plus the 5 plus the 4 plus the 4 plus this mystery number should get us to a perimeter of 24. So let's add over here and try to make it a little simpler to find our missing side. I can add in any order, and I love making tens, so I'm going to say 6 and 4 is 10. 10 plus 5 is 15, and 15 plus 4 more is 19. So we know where 19 centimeters come from on this shape. Here's the 19 centimeters are here outlined in blue. So how many more centimeters, what length must this missing side be to get us a total distance around the outside of 24 centimeters? We can do that math. 19 plus 1 more is 20, and then plus 4 more to 24. So 1 more to 20 and 4 more. That's a total of 5 more. So the missing side length is 5 centimeters. This side right here must be 5 centimeters in order for the total perimeter to be 24. Okay, let's look at one more. This time it says that the perimeter of a rectangle is 32 meters and one side is 11 meters. What is the length of the missing side? So again, we have a missing side. So let's visualize this. Let's draw ourselves a rectangle here. It says what a rectangle looks like. And we know that one side is 11 centimeters. So one side is 11, or meters, excuse me. And because we know that this side is 11 meters, we also know that this side is 11 meters. On a rectangle, opposite sides are equal. So those two we know. But what we don't know are this top and the bottom. Those are the missing sides. So what are those side lengths? Well, again, we know we have a perimeter of 32 meters. We're told right here perimeter is 32 meters.
But it's actually...
So the question is 11
the longer side.
Plus 11
22.
for these.
So you're going to have 5.
For these two sides, 11 and 11, plus some mystery number, and then plus that same mystery number, because these two sides are equal, and that has to give us a total of equals 32, because 32 is the total distance around the outside. So let's add the 11s. 11 plus 11 is 22. So 22 plus
10.
How many more gets us to 32?
5 plus 5.
Well, 22 plus 10 more is 32. But if we label one of these sides as 10, then the other one would have to be 0. So they have to be equal. So how can we equally split those 10 meters between the two sides? Half of 10 is 5. So these sides are each 5 meters. 22, 5 plus 5 is 10. 22 plus 10 is 32. So the missing side length is 5 meters.
Let's see our recording. Okay, it shows here that we're recording. Yeah, it does. Cool. Ubuntu for the win. 20.04.
Charles built a rectangular table that has a perimeter of 20 feet and an area of 24 square feet. The table is longer than it is wide. What are the length and width of the table? The length and width are whole numbers. So it's longer than it is wide. So let's draw this table here. So the table might look something like this. Might look something like this. Where this dimension right over here is the length. So this distance right over here is the length.
Or 8 and 4.
We could also write length here if we want to show that this is the same, these two sides have the same length. And then we could call this dimension right over here, this is the width. This is the width, and this is also, of course, the width as well. This is a rectangle. So these two sides are going to be the same. Now they tell us that the perimeter is 20 feet, which is another way of saying that the width plus the width plus the length plus the length plus the length
actually 8 and
is
2.
equal to 20.
Length of 8 and
is
width of
equal
2.
to 20. And they tell us that the area is 24 square feet. That's another way of saying that the width times the length is going to be 24. So we could write that down.
Oh no,
width
16.
Width times the length
Wow, this is really
is
hard.
going to be equal to 24. Now there's a lot of ways to solve this problem, and later on when you learn more algebra, there's fancy algebraic ways to do that, but we won't have to resort to this. They tell us that the length and width are whole numbers, so we really should just be able to try out some numbers, because we know that the width times the length is 24. So we just have to try out all of the whole numbers that when I were to take their product, I get to 24, essentially the factors of 24, and then figure out which of those satisfy the perimeter up here, where if I take the width plus the width, essentially 2 times the width plus 2 times the length, I'm going to get to 20.
6 times 4
so let's figure that out. So let me make 2 columns here. So one column, I'm going to call it a width column. Another column, I'm going to call it length.
Cool. Wow.
And then I'm going to write down the perimeter. I'll write perimeter. I'll just shorten it with per, maybe peri. I'll just write out the whole word. Perimeter. And then let's write out area. Let's write out area. Actually, let's do, well, I could write it just like that. And let me try out, make it a table here. So I have a table here, and then I can try things out. And what we can do is just make sure that everything we try out has an area of 24 square feet. So let's just think about the factors of 24. Well, it could be 1 and 24. So this literally could be 1, a width of 1, and a length of 24. 1 times 24 is 24. And they tell us that the length is longer. The length is longer than the width. That the table is longer than it is wide. So we want the larger number under length. So let's see. 1 times 24 is 24. But what is 1 plus 1 plus 24 plus 24? Well, that's going to be 2
50.
plus 48, which is 50. So this doesn't meet our condition that the perimeter is 20. So let's cross that out. So this one right over here, does not work out. Let's try the other factors of 24. It could be 2 and 12. Once again, 2 times 12 is 24. But what's 2 plus 2? It's 4 plus 12 plus 12. So it's 4 plus 24. That's going to be 28. Well, that doesn't meet our perimeter constraint. So we can, that's not going to be right. Well, what about, let's see, 3 times 8 is also equal to 24. And what's 3 plus 3 is 6, plus 8 plus 8 is 16, 6 plus 16 is 22. Well, we're getting close, but it's still not a perimeter of 20. So that's not going to be right. Now, what about 4 and 6? Once again, 4 times 6 is 24. And what's 4 plus 4 plus 6 plus 6? Well, that's 8 plus 12, which is indeed equal to 20. So that works out.
Yeah.
Our width is going to be 4 feet, and our length is going to be 6 feet.
And we're done. Why you say that anymore?
Mike built a rectangular dog pen that is 21 feet long and has a perimeter of 78 feet. What is the width of Mike's dog pen? So let's draw what it might look like. So it might look something like this. Do my best to draw it. A rectangular potential dog pen. So let's say that this is the dog pen right over here. And they give us its length. Its length is 21 feet. Its length is 21 feet. So this distance right over here is 21 feet. And of course, if that distance is 21 feet, this distance is also going to be 21 feet. Now they also tell us that the perimeter is 78 feet. So the perimeter is 78 feet. 78 feet. So we need to figure out the width. And the width would be this length, or this width, I should say. This width, which is going to be the same thing as that width right over here. So let's think about, and we know how we figure out the perimeter. If we added this distance, 21 feet, to this distance, the width, plus 21 feet to the width again, we're going to get to 78 feet. So one way to back into what the width is to say, well, look, if we sum up all of these lengths, we're going to get 28 feet. So let's at least subtract these two orange lengths, the 221 feet, from the 78 feet. And then we figure out how much length, essentially, these two widths have to make up. So let's subtract. Let's do 78 minus 21 minus 21. And what's that going to be equal to? So that's 78 minus 42. And 78 minus 42, I don't want to make a careless mistake. 78 minus 42 is going to get me to 36. So this is equal to 36. And let's remind ourselves what 36 is, what 36 feet is. That's the total length, or I should say the total width, if we were to take the width down here and add it to the width up here. Now we know something else. These are the exact same width. That this distance is the same as this distance. And if we add them together, we get to 36. So what are two distances, or what are two numbers that I can add together to get to 36?
18, bro.
Well, we know that 18 plus 18, we know that 18 plus 18 is equal to 36. So this one down here must be 18, and this one up here must also be 18. And we can verify that. Try adding all of these up together. You add the two widths, you get 18 plus 18, and you add the two lengths, plus 21 plus 21, and you are left with 36, which is exactly what we got here. This is what we needed the two widths to add up to, plus 42, which is, of course, equal to 36 plus 42 is equal to 78, which is the perimeter.
Cool. Activity. You want to do the activity now? Okay. 3, 6, 1, 2, 3, 4, 5, 6, 12, 18. Oh my god. Wow, cool. Okay. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. It's just 4, 7, 10, 11, 12, 13, 14. Please 14. Thank you. Okay, this is 4, 1, 2, 3, 4, 5, 6, 7. 14 plus 4, 18, please. Cool. What's the perimeter of the trapezoid? Okay. It's be 38, 46. Wow, this is hard. 30, 48, I guess. Wow, 15. Is this hexagon? Yeah, it is. So you have 30, 90. Wow. Oh, crap. Okay. One side of a regular action is 9 units. What is the perimeter of the hexagon? 4. What is the perimeter of the figure? Wow, okay. 18, 22. Cool. Hexagon, 3 times 6 and 18. What's this? 20, 80, 40 plus 28, 68. Oh shit. Okay. Two answers. Amazing, cool. The triangle below is a perimeter of 27. What is its side? Okay, it's given 9. Oh, okay. The perimeter of 26. So 14, 18, 14, 18, 21, 5. Rectangle is 32. One side is 11. Oh shit, we've already solved this, right? It's 5. We're off. I hate word problems. The area of a rectangle is 28. Length is 7, so I have 14. And then to get from there to 28, and 7 again. Whoa, no way. Oh my god, I hate word problems so much. The area of a rectangle is 28 square meters. Oh, it's saying area. Holy crap, I thought perimeters. Fucking hell, bitch. Okay, cool. So, what's it for? Oh god, I hate it. Rectangle is a width of 10 centimeters. Rectangle's length is 4 times its width. Rectangle is 10. Has a width of 10 centimeters. And the rectangle is 4 times its width. Okay, so we have 40 and 10, right? 100, I guess. Chloe has enough sand to fill a sandbox. She wants the outer edges of the sand to as little material as possible. She wants the outer edges of the sandbox to use as little material as possible. Smallest perimeter. Oh, okay. Oh, so this one's 36. Oh, this one's 36. This one's 36. The fuck? I'm calculating the area. 18. 18 plus 18, 26. 24. Oh, what's this? Calculate should be. What perimeter of a rectangle is 20 centimeters? What? A square. I believe this is 12 times 12, right? A square's perimeter of 36. What is the area of the square? Wow, what's this? It's gonna 4 by 9. 1826. What? If it's 36 and it's 4 and 9, right? Then if you add all those 18 plus 8, that's 26. Holy shit. Oh, what? 6, 1, 26. What is the area of the square? Oh shit, I think I got it wrong. I mean, the perimeter is 36. I mean, I could have like 9/4. Right, so it's 81. The area of a rectangle is 42. The length is okay. So we have 42 and 7. What's the perimeter of the rectangle? I guess it's 6. No, not really. 14. So area is 42. So 6. That's gonna be 42, right? So what is the perimeter? Oh, okay. So 26. Let's try again. Why does word problems have to be 7 questions? Well, this easier ones only has 4 questions. It should be the other way around. A rectangle playground is 8 meters wide. It is 3 times as long as it's wide. What is the area? Okay, so we have 8 by 24, right? A rectangular playground is 8 meters wide. It is 3 times as long as it is wide. Yeah, okay. So what is the area? So 24 times 8. 2, 3, 16, 19, 1, 2. Margot has 24 meters of wood to build a fence around her garden. She wants to create the largest area possible. Margot has 24 meters of wood to build around the largest area possible. Okay, this is 36. This is 32. This is okay. Lisa built a rectangular flower garden that's 4 meters wide. What is the length of Lisa's flower garden? Okay, a perimeter of 26. So we have like 8. And then it's gonna be 8, right? So that's 16 plus 8 and 4. Oh shit, it's actually 26. So this could be 9. 9. So we have 18 plus 8. 6, 9. A square is an area of 100 square meters. What is the perimeter of the square? No, not really. A square is an area of 100 meters. So this should be 100. And if it's square, then all sides are like equal, right? Wow, this is insane. Oh, actually it should be just 10. So we have like 40. Right? Oh my god, I don't want to be wrong, but it should be 40. Cool. Steve built a square hamster pen that is perimeter 240. What is the length of one side of Steve's hamster pen? What the fuck? Perimeter of 240. 240p. What is the length of one side of Steve's hamster pen? What the fuck? Oh, a square. Square, not right. It's gonna be like 7. No, not real 7. It should be 6. 60, right? Cent perimeter square 240. Excuse me. Let's build a large rectangular vegetable garden that's 9 meters long. Rectangular garden that's 9 meters long. And it's an area of 72. It's gonna be 9 times 8 to get 72. 18 plus 16. We have 14, 34. Its perimeter is 34, right? Oh my god, I don't want to be wrong. But it should be 34. A rectangle is a width of 3, length of 5. What is the area? Oh fuck, I almost do 3 times 5. The rectangular's length is 5 times its width. So we have 15 and 3, so it's gonna be like 45 the area. Cool. Okay, let's do the quiz. See, this is bullshit. Your quiz has 5 problems, and then your word problem is like 7 questions. Jordan has 30 meters of border to create his classroom bulletin board. He wants to create the largest area possible. Here's 50. That's 36. Oh wow, this is 56. This is pretty insane. We're going to see. What's the perimeter of the figures? What's the length of the missing side? Perimeter of 31. You have 18, 24. You're missing 7. One side of a regular triangle is 5 units. What is the perimeter? The perimeter of a rectangle is 32 centimeters. The width is 7 centimeters. What is the area of the rectangle? Okay, so if this is 7, wait, what? The perimeter of a rectangle is 32, right? The width is 7. So I have 14. 32 minus 14. We have 12 and 2, 4. What's this? What number is this? This is 12. So we have 8. Oh my god, I'm not even sure about that. So we have 18. What's that? It's 18 plus 14, right? 12. 32. So we have 18. 9. 9 times 7. 63. Oh my god, I could be wrong, but this is correct. A triangle is a perimeter of 24. Triangle is 24, so it's gonna be 8. What's that one? It's gonna be 8. Okay, cool. Oh yeah, volume per rectangular prism. Wow, pretty close, right? I believe I'm not even an hour in. 38 minutes in only. Let's go. Volume.
Human beings have always realized that certain things are longer than other things. For example, this line segment looks longer than this line segment. But that's not so satisfying just to make that comparison. You want to be able to measure it. You want to be able to quantify how much longer the second one is than the first one. And how do we go about doing that? Well, we define a unit length. So if we make this our unit length, so we say this is 1 unit, then we could say how many of those lengths are each of these lines. So this first line looks like it is, we can do 1 of those units, and then we can do it again. So it looks like this is 2 units. While this third one looks like we can get, let's see, that's 1, 2, 3 of the units. So this is 3 of the units. And right here, I'm just saying units. Sometimes we've made conventions to define a centimeter, where the unit might look something like this, and it's going to look different depending on your screen. Or we might have an inch that looks something like this. Or we might have a foot that I won't be able to fit on this screen based on how big I've just drawn the inch, or a meter. So there's different units that you could use to measure in terms of. But now let's think about more dimensions. This is literally a one-dimensional case. This is 1D. Why is it one dimension? Well, I can only measure length. But now let's go to a 2D case. Let's go to 2 dimensions, where objects could have a length and a width, or a width and a height. So let's imagine 2 figures here that look like this. So let's say this is one of them. This is one of them. And notice it has a width and it has a height, or you could view it as a length or you could view it as a width and a length, depending on how you want to view it. So let's say this is one figure right over here, and let's say this is the other one. So this is the other one right over here. Try to draw them reasonably well. Now, once again, now we're in 2 dimensions, and we want to say, well, how much in 2 dimensions space is this taking up? Or how much area are each of these 2 taking up? Well, once again, we can just make a comparison. This second, if we view them as carpets or rectangles, the second rectangle is taking up more of my screen than this first one, but I want to be able to measure it. So how would we measure it? Well, once again, we would define a unit square. Instead of just a unit length, we now have 2 dimensions. We have to define a unit square. And so we might make our unit square.
Bigger, right?
And the unit square we will define as being a square where its width and its height are both equal to the unit length. So this is, its width is 1 unit and its height is 1 unit. And so we will often call this 1 square unit. Oftentimes you'll say this is 1 unit, and you put this 2 up here. This literally means 1 unit squared. And instead of writing unit, this could have been a centimeter. So this would be 1 square centimeter. But now we can use this to measure these areas. And we say, well, how many, just as we said, how many of this unit length could fit on these lines, we can say, how many of these unit squares can fit in here? And so here, we might take one of our unit squares and say, okay, it fills up that much space. Well, we need more to cover all of it. Well, there, we'll put another unit square there. We'll put another unit square right over there. We'll put another unit square right over there. Wow, 4 unit squares exactly cover this. So we would say that this has an area of 4 units, 4 square units, or 4 units squared. Now what about this one right over here? Well, here, let's see, I could fit 1, 2, 3, 4, 5, 6, 7, 8, and 9. So here I could fit 9 units squared. Let's keep going. We live in a 3-dimensional world. Why restrict ourselves to only 1 or 2? So let's go to the 3D case. And once again, when people say 3D, they're talking about 3 dimensions. They're talking about the different directions that you can measure things in. Here there's only length. Here there's length and width, or width and height. And here there'll be width and height and depth. So once again, if you have, let's say, an object, and now we're in 3 dimensions, we're in the world we live in, that looks like this, and then you have another object that looks like this. It looks like this. It looks like this second object takes up more space, more physical space than this first object does. It looks like it has a larger volume. But how do we actually measure that? And remember, volume is just how much space something takes up in 3 dimensions. Area is how much space something takes up in 2 dimensions. Cool. Length is how much space something takes up in 1 dimensions. But when we think about space, we're normally thinking about 3 dimensions. So how much space would you take up in the world that we live in? So just like we did before, we can define, instead of a unit length or a unit area, we can define a unit volume or a unit cube. So let's do that. Let's define our unit cube. And here, it's a cube, so all of its length, width, and height are going to be the same value. So my best attempt at drawing a cube. And they're all going to be 1 unit. So it's going to be 1 unit high, 1 unit deep, and 1 unit wide. And so to measure volume, we can say, well, how many of these unit cubes can fit into these different shapes? Well, this one right over here, and you won't be able to actually see all of them. I could essentially break it down into, so let me see how well I can do this so that we can count them all. It's a little bit harder to see them all because there's some cubes that are behind us. But if you think of it as 2 layers, so one layer would look like this. One layer is going to look like this. So imagine 2 things like this stacked on top of each other. So this one's going to have 1, 2, 3, 4 cubes. Now this is going to have 2 of these stacked on top of each other. So here you have 8 unit cubes, or you could have 8 units cubed volume. What about here? Well, if we try to fit it all in, let me see how well I can draw this. It's going to look something like this. Obviously, this is kind of a rough drawing. And so if we were to try to take this apart, you'd essentially have you'd have a stack of 3 sections that would each look something like this. My best attempt at drawing it. 3 sections that would look something like what I'm about to draw. So it would look like this. So if you took 3 of these and stacked them on top of each other, you would get this right over here. And each of these have 1, 2, 3, 4, 5, 6, 7, 8, 9 cubes in it. 9 times 3. You're going to have 27 cubic units in this one right over here. So hopefully that helps us think a little bit about how we measure things, especially how we measure different things in different number of dimensions, especially in 3 dimensions when we call it volume.
Volume. 3 dimensions. Cool.
We are asked, what is the volume of this box? And they tell us that each cube is a cubic foot. So just as a reminder, a volume is a measure of how much space does something take up. And it's usually measured in cubic units. And here we're talking about cubic feet. And when they say that each cube is a cubic foot, they're saying that each of these little boxes, each of these cubes here, is exactly a 1 foot by 1 foot by 1 foot cube. We're in 3 dimensions right now. And we're talking about 3 dimensions. 3D, you literally need 3 dimensions. You need how tall you are, how wide you are, and how deep you are. And for a cubic foot, each of those dimensions is 1. So each of these are 1 cubic foot. The entire shape has 1, 2, 3, 4, 5, 6 cubic feet in it. So the volume of this entire box is 6 cubic feet. And you see right here the unit has feet, and it has a superscript here of 3. This is feet to the 3rd power. You could view this as feet times feet times feet, or cubic feet. So this is 6 cubic feet. Let's do a few more of these. What is the volume of this shape? So this one is quite interesting right over here. You have, let's see if we can count these. So you have 1, 2, 3, 4, 5, 6, 7, 8. 8 unit boxes, or I guess these are cubic inches for this example. So so we have 8 cubic inches. This is a lot of fun, especially when we get to rotate it. So here, each cube is a cubic foot again. So we have 1, 2, 3 cubic feet. 3 cubic feet. Let's do one more of these. I like the ones that have these kind of crazy shapes that we have to rotate to be able to see all the boxes.
Oh, yeah,
so each of these is a cubic meter, which means that in each dimension, each of these boxes is a 1 by 1 by 1 meter. But how many boxes are there? Let's see. We have one. Let me see, get a view where I can look at it better. We have 1, 2, 3, 4, 5, 6 boxes. So the total volume here is 6 cubic meters.
And we're done. Why you didn't say that anymore?
I have this figure here. You could call it a rectangular prism. And I want to measure its volume. And I'm defining my unit cube as being a 1 centimeter by 1 centimeter by 1 centimeter cube. It has 1 centimeter width, 1 centimeter depth, 1 centimeter height. And I will call this this is equal to 1
times 3
cubic
times 4. Wow.
cubic centimeters. So I want to measure this volume in terms of cubic centimeters. We've already seen that we can do that by saying, hey, how many of these cubic centimeters can fit into this figure
24.
without them overlapping in any way? So if we had this, in our hands, we could kind of try to go around it and try to count it, but it's hard to see here because there's some cubes that we can't see behind the ones that we are seeing. So I'm going to try different tactics at it. So first, let's just think about what we can observe. So we see that this one, if we measure its different dimensions, its width, it's 2 of the unit length wide. So it's 2 centimeters wide. It's 4 of our unit length. We're defining our unit length as a centimeter. It's 4 of our unit length high. So this dimension right over here is 4 centimeters. And it is 3 of our unit length deep. So this dimension right over here is 3 centimeters. So I want to explore if we can somehow use these numbers to figure out how many of these cubic centimeters would fit into this figure. And the first way I'm going to think about it is by looking at slices. So I'm going to take a slice. I'm going to take this slice right over here of our original figure. And let's think about how we can how using these numbers we can figure out how many unit cubes were in that slice. Well, this is 2 centimeters wide, and it is 4 centimeters high. It is 4 centimeters high. And you might be saying, hey, Sal, I could just count these things. I could get 8 squares here. But what if there was a ton there? It would be a lot harder. And you might realize, well, I could just multiply the width times the height. That would give me the area of this surface right over here. And it's only 1 deep, so that also will give me the number of cubes. So let's do that. Let's find the area here. Well, that's going to be 2 centimeters times 4 centimeters. 2 centimeters times 4 centimeters. That gives us the area of this. And then if we want to find out the number of cubes, well, that's also going to be equivalent to the number of cubes. So we have 8 square centimeters is this area, and the number of cubes is 8. And if we want the number of cubes in the whole thing, we just have to multiply by the number of slices. And we see that we need 1, 2, 3 slices. This is 3 centimeters deep. So we're going to multiply that times 3. So we took the area of one surface, we took the area of this surface right over here, and then we multiply it by the depth. That essentially gives us the number of cubes, because the area of this surface gives us the number of cubes in a slice that is 1 cube deep, and then we would have to have 3 slices like that. So we would have to have, this is 1 slice, we would have to have another slice, and then another slice in order to construct the original figure. So 2 centimeters times 4 centimeters times 3 centimeters would give us our volume. Let's see if that works out. 2 times 4 is 8 times 3 is 24. 24, let me do that in that pink color. 24 centimeters cubed, or I could say cubic centimeters. So that's one way to measure the volume. Now, there's multiple surfaces here. I happen to pick this surface, but I could have picked another one. I could have picked this surface right over here and done the exact same thing. So let's pick this surface and do the exact same thing. This surface is 3 centimeters. 3 centimeters by 4 centimeters by 4 centimeters. Let me do that in that blue color. Color changing is always difficult. By 4 centimeters. So its area is going to be 12 square centimeters is the area of this surface, and 12 is also the number of cubes that we have in that slice. And so how many slices do we need like this in order to construct the original figure? Well, we need, it's 2 centimeters deep. This is only 1 centimeter deep, so we need 2 of them. We need 2 of them to construct the original figure. So we can essentially find the area of that first surface, which was 3 times 4. 3 times 4, and then multiply that times the width, times how many of those slices you need, so times 2. And once again, this is going to be 3 times 4 is 12, times 2 is 24. I didn't write the units this first time, but that's going to give us the count of how many cubic centimeters we have, how many unit cubes we can fit. So once again, this is 24 cubic centimeters. And you can imagine you could do the same thing, not with this surface, not with this surface, but with the top surface. The top surface is 3 centimeters deep, 3 centimeters deep, and 2 centimeters wide. 2 centimeters wide. So you could view its area, or its area is going to be 3 centimeters times 2 centimeters. So that area is, we do the same colors, 3 centimeters times 2 centimeters, 2 centimeters, which is 6 square centimeters. And that also tells you that there's going to be 6 cubes in this 1 cube deep slice. But how many of these slices do you need? Well, you have, this whole thing is 4 centimeters tall, and this thing is only 1 centimeter, so you're going to need 4 of them. So that's 2, 2, 3, 3, trying to draw it as neatly as I can, 3, and 4. You're going to need 4 of these. So to figure out the whole volume, you're going to have to take that and multiply that times 4 centimeters, which once again, 3 times 2 is 6 square centimeters times 4 centimeters is 24 cubic centimeters. So it doesn't matter what order you multiply these in. You could view this, take the one area of one side and multiply it times the depth, or you could take the surface area of another height and multiply it times the height or the width or the depth. And these are all the scenarios. But what it shows is it doesn't matter what order we multiply these 3 dimensions in. You could view it, you could take the 2 times the 4 first and then multiply by the 3, or you could take the 3 times the 4 first and then multiply by the 2, or you could take the 2 times the 3 first and then multiply by the 4. When you're multiplying, it doesn't matter what order you're doing these in. And so if you have a rectangular prism like this, and you know it's 3 dimensions, you know it's 2 centimeters wide, 3 centimeters deep, and 4 centimeters tall, you can say, hey, the volume of this thing, the number of unit cubes, the number of cubic centimeters it can fit is going to be 2 centimeters times 4 centimeters times 4 centimeters times 3 centimeters, which we've seen 3 times already is 24 cubic centimeters. What is the volume of this box? Drag on the box to rotate it. So this is pretty neat. We can actually sit and rotate this box.
Oh, yeah,
but we've already
satisfying.
seen, and here it looks like everything's being measured in meters. So we want to measure our
56
volume
times
in
6.
terms of cubic meters. That's going to be our unit cube here. So when we want to think about how many cubic meters could fit in this box, we've already seen examples that you really just have to multiply the 3 different dimensions of this box. So if we wanted the number of cubic meters that could fit in here, it's going to be 6 meters times 8 meters times 8 meters times 7 meters, which is going to give you something in cubic meters. So let's think about what that is. 6 times 8 is 48. Let me see if I can do this in my head. 48 times 7, that's 40 times 7, which is going to be 280, plus 8 times 7, which is 56. 280 plus 56 is going to be 336. 336. Let's check our answer. Let's do one more. 6, which is going to be 280 plus 8 times 7, which is going to be 287. 8. Let me see if I can do this in my 6 times 8. Something in 8 is 48. Let me see if I can do this in my head. 48 times 7, that's 40 times 7, which is going to be 280, plus 8 times 7, which is 56. 280 plus 56,
wow, that's insane.
which is going to be 200 times 7.
So you have 48 times 7, and then you have like 40 times 7, 280 plus 6 times 7.
That's 40 times 7, which is going to be 280, plus 8 times 7, which is...
Wait, why 8? 448. No, so 4 times 7 is 280. And then
is 56. 280 plus 56 is going to be 336.
And we're done.
336.
Cubic meter.
Let's check our answer. Let's do one more of these. So what's the volume of this box? Well, once again, we have its height at 6 feet. Now everything's being measured in feet. We have its, I guess we could call it its width being 4 feet. So we can multiply the height times the width of 4 feet. And then we can multiply that times its depth of 2 feet. So times its depth of 2 feet. So 6 times 4 is 24, times 2 is 48 feet. 48, and I should say cubic feet. We're saying how many cubic feet can fit in here. When we multiply the various dimensions measured in feet, we're essentially saying, we're counting almost how many of those cubic feet can fit into this box.
Word problem, I hate it.
A water tank is 12 feet high, 5 feet long, and 9 feet wide. A solid metal box, which is 7 feet high, 4 feet long, and 8 feet wide, is sitting at the bottom of the tank. The tank is filled with water. What is the volume of the water in the tank? So let's think about this. We have a water tank. It's 12 feet high. Try to draw this as good as I can. So it's 12 feet high. It's 5 feet long. So this looks like that's about 5 feet. And it's 9 feet wide. So this is my best rendition of what the tank looks like. So the tank might look something like this. That is my water tank. Let me draw it. Draw the whole thing. So there's my water tank. And I'm going to make it transparent so that we can see what's going on inside of the tank. So here we go. There's like a helicopter outside or something. I don't know if y'all hear that. But let's see. So there is my water tank. 12 feet high. 12 feet high, 5 feet long, and 9 feet wide. 9 foot wide. And then they say there's a solid metal box, which is 7 feet high, 4 feet long, and 8 feet wide, sitting at the bottom. Sitting at the bottom. So let's see if I can draw that. So let's say it's 4 feet wide, 4 feet, or I guess we could say 4 feet long, 7 feet high. So let's see, 4 feet might look something like this. It's 7 feet high, which might look something like that. 7 feet high. Obviously, I'm not drawing it perfectly to scale. 7 feet high and 8 feet wide. So it might look something like this as it's sitting in this tank. So this is that metal box. And and they say it's a solid metal box. It's not like any water can fit in here. So let me make it as a solid metal box. So this is a solid metal box. And then I'm going to fill the whole thing. I'm going to fill the whole thing with water. I'm going to pour water into this thing. And the water is going to start filling up. And it's going to fill up all the volume of the tank except where the metal box is. It's not going to be able to fill in that volume because the metal box is solid. So it's going to fill up. We're going to fill it, slowly fill this thing up around the metal box. So what's the volume that it's going to fill up? Well, it's going to fill up the volume of the tank minus the volume of the metal box. It couldn't fill in the metal box volume. So let's figure out what that is. The volume of the tank is going to be 9 foot by 5 foot times 12 feet. That's the volume of the tank. Tank volume. Tank volume. And from that, we want to subtract the metal box volume. So minus 4 foot by 8 feet. By 8 feet, 8 feet by 7 feet, by 7 feet, by 7 feet. This is 4 feet wide. It is 8 feet. What do they? Oh, they say it's 7 feet high.
Oh, yeah,
7 feet high. It's 4 feet long and it's 8 feet wide. 8 feet wide. So this right over here is the volume. This is the, I guess we could call it the metal box volume. The box volume. And so what's in between, or when you take the tank volume, subtract out the box volume, that's how much the water can actually fill in. So I only do the water partially filled, but once it's already filled in, the water's going to go all the way to the top here, and it will fill in everything except for where that blue box is. So let's figure out what this value is. So 5 times 12 is 60. 60 times 9 is 540. And then in blue here, let's see, 4 times 8 is, so 5 times 12 is 60. 60 times 9 is 540. And then in blue here, let's see, 4 times 8 is 32. 32 times 7 is 210 plus 14, which is 224. So it's 4 times 8 is 32. 32 times 7 is 210 plus 14, which is 224. So it's minus 224. Minus 224. Did I do that? 24. 2 times 110 plus 32. 32 times 7 is 210.
So 21. 2. Wait, what? So 14. Then 3, 201 plus 14. Oh, we did it the 3 times 4, 3 times
10
7
plus
first.
14, which is 224. So it's minus 224.
32
Minus 224. Did I
plus
do that right? I don't want to make a careless mistake. So 32 times
yeah,
7. 2 times 7 is 14.
Wow, insane.
3, which is really a 30 here. 30 times 7 is 210. Plus another 10 is 220. So 224. So this is going to be equal to, let's see, 500 minus 200 is 300. 300, and then 40 minus 24 is 16. 316. And our units are in cubic feet. So the volume of the water in the tank, 316 cubic feet.
Feet cube. Okay, cool. What is the volume of the rectangular prism? Gonna be 2 times 5, 10 times 20. Supposed to be? I don't know. Okay, 1, 2, 3, 4, 5, 6. Looks like 6. 1, 2, 3, 4, 5, 6, 12, 24. 1, 8. Okay. 16. 4, 5, 6, 7, 8. It's gonna be 4. Start with 35, 71, 40, 9, 7. What's this? This is 24 times 3. 52, right? Oh, not actually 52, it's more than that. Times 3. 12, 5, 62. What? 72. Yo. Oh shit, same shit? I hate word problems. Okay, I have to build a box for my scouting project with a volume 36 cubic meters. Centimeters. The base of the box is 6. And 12. 3. Rectangular position by toy chest 2 by 1 by 1. A shipping crate is packed with 18 of these toy chests. There's no extra space in this crate. What is the volume of the crate? It's like 2. Then it's been 9, right? Wait, what? No, not 9. A shipping crate is packed with 18 of these toys. Okay, so we have 18 times 2, right? So he'll have to do that, so it was 36. Oh my god, I could be wrong, but let's see. Cool. I bought a box from the post office that has 24 volume cubic centimeters. Could choose all answers that apply. Okay, so it's cubic, so as now, this could work. 4, 69 works. So my mom built a new sandbox that is 3 meters long, 2 meters wide, and 1 meter high from existing. Sand for the sandbox costs 4.5 per cubic meter. Wow. Okay. So you have 4.5 times 6. It's 30. It's 30. Yeah, 24. 27. $7. I'll say quiz the unit. Wow, it's pretty quick. How much? I've been in 1 hour already. Close to the unit quiz. Okay. Yung sa aquarium is filled with 2 meters of water. The base. Okay, so let's see. 20, 12. I guess it's kind of 240, but let's see. 0, 4, 0, 2, that's 240. 240 times 10. Okay. This is like 9 times this, 18. The sea turtle habitat at the zoo is made by connecting 2 large aquariums. The first aquarium is 24 48, and the second aquarium is what's this? 8 times 72 times 3, we have 6, we have 21, 116, 6, 21, yeah, correct. So 14, 264, please. Cool. What's the ball of the rectangular prism? We have, oh my god, what's happening? Okay. So we have 1, 2, 3, 4, 5. So 6. Backs of granola bars of bottom 210. Which is found to be the dimensions of the box. It could be this one, that's 1 at 10. What else? This ain't it. How about this one? 30 times 7. Okay, let's see if this. Wow, cool. So the unit test, 9 questions only. Okay, cool. The square is an area of 49 square meters. What is the perimeter of the square? 7. 28. It's because 7 times 7 square. It's gonna be 49. It's gonna be 8 times 3 is 24. Let's verify that. We have like 4 times 2, 8 times 3. Erin built a wooden box to hold hay on her farm. The box is 3 meters long and 1. Okay. Hey now, $42. But let's be sure. Long, wide, 3. Oh shit! Wait, what? No, yeah, it's actually just 3. Then each of that's gonna be like 14, so it's gonna be 42, right? Okay, cool. What's the perimeter of the triangle? Oh, it's gonna add all the shit up. Let's do 48 and 55 first. So we have 13 and 10 plus 36. 9, 3, 1, 3, 9 centimeters. The area times 42, the length is 7. Okay, they're telling me that this is 7, so let's put 7 there. The length L 7, and then the area of the rectangle is 42. The perimeter is actually not given, so I guess it's also not given. So it's supposed to be it. The fuck? What is this? What is the area of the shape? 2 times 1, 2, 3, 4, 5. What square in the grid is a unit square with an area of 1 square unit? Oh my god, this is hard. Okay, cool. Each square in the grid is unit square. Okay. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Should be 10, right? So 4, 5, 6, 7, 8, 9, 10. Yeah. What is the perimeter of the rectangle? The perimeter, oh, actually, it's 40, the perimeter. So it's 13, it's going to be 13 as well, so it's going to be 26. We have 14, 7. Which rectangles have an area of 20 square units? Can we do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh yeah, mastered. Mastered. That's pretty fast. Just an R in, so we're gonna do some more. Okay. What's next? Let's think next. Well, it should be next, but we already done this back in arithmetic, so we're gonna whoa, negative numbers in coordinate plane. Oh, cool. It's mastered. Oh my god, quiz. Let's do the quiz. What is this about? It's negative numbers, right? Can I ask this regarding where negative numbers and how would losing 15 points? Lowest on the left. Where is the blue point on the number line? 10, 15, 20, negative 20. Last month, Louisa's bank statement said that she had money in her account. Her bank balance was 109.30 rubles. What does this mean? Oh, overdrew. Okay. Where is the blue point on the number line? 7, 14, 21, 28, 35. Negative 35. Okay, so it's done. Oh my god, I'm gonna do the quiz again. Wow, I only need to do the quizzes. Wow, okay, I'm gonna finish this now. I'm just gonna take a pee. Oh shit, where's the pause? There's no pause button, what the fuck? This is insanely weird. Sec, I'm gonna take a pee. Right, I'm back. How's your recording? There's no pause button. What the fuck? Okay, sure, whatever. Should the following is represented as 103, 4, 10, 2 quarts. There's some negative here. It should be just 3/4 minus 2. Minus negative 3/4, no. What is the opposite of, I guess, negative 6/7? Least to greatest. This looks like least. This looks like the greatest. And 71 and 1/3. Okay. That's 71. That's 9/4. That's 4. That's not A or B or B minus A. Fill in the blank. Oh wow. Okay, it's greater. This is 2/5. Well, this is 7/5, and it's an absolute value, so it's gonna be greater. Wow, this is getting fast. Okay. Quiz 2 and quiz 1 all done. Yeah, let's go to quiz 3. Okay, what is this about though? What's this about? Adding, subtract negative numbers? Okay. Let's see. Which expression is equal to negative 36 minus 8? Oh, okay. Negative 36 plus negative 8. Yeah. Evaluate. Okay, let's do that. It's gonna be 8 and 9 minus 8. It's gonna be 1. Let's be sure. This is quiz. It's gonna be 8 and it's gonna be 1. Yeah. Subtract. Wow. Which expression is equivalent to 16.8 minus 18.6? 16.8 and 18.6. Evaluate negative 122 minus 14. Okay, so it's gonna be negative 22, negative 36. Negative 36 minus negative 22. So it's gonna be turned into plus, so it's gonna dice out. So we're on the, oh wow, this is 0. Okay, cool. Oh my god, quiz 4. Okay. What is the sign of when x is greater than 0 and y is less than 0? It's negative. Negative 6, right? Yeah. What is the sign of negative 4 divided by negative 8? It's gonna be positive. Negative 18. Wow, that's insanely fast. Okay, so we're gonna do this now. Oh shit, I can finish this.
What we're going to do in this video is...
What am I recording? I am recording. Why am I always paranoid about this shit? And I don't have a pause button. That's insanely weird.
Through a bunch of examples,
Why you do this?
What we're going to do in this video is, through a bunch of examples, familiarize ourselves with the xy coordinate plane. And first, we're going to just look at some points that are already plotted and figure out their coordinates. Then we're going to look at some coordinates and figure out where those points are. And then we'll do one more problem. So let's figure out what are the coordinates of these points. So you have this point right here, A.
A
So
is
its x-coordinate, you can see it right there. You just drop down. Where does it intersect the x-axis? X is equal to 5. So it's the point 5, comma, and y is going to be equal to 6. 5, comma, 6. Now this point B here, what's the x-coordinate? It is 5 to the left. 5 to the left of the x-axis. This is negative 5. X-axis, x-coordinate is negative 5. Y-coordinate is, if you just go straight to the right, you're going to hit y is equal to 5. Y is equal to 5. Let me switch colors. C. I think you're getting the hang of this. Let's do the y-coordinate first. The y-coordinate is 3. You see that right there. And then the x-coordinate is negative 2. Negative 2. You always put the x-coordinate first. That's just the convention we use. D. X-coordinate, negative 2. You see that right there. Y-coordinate, negative 2 as well. Let me get another color. E. Let's do the y-coordinate. Well, we'll figure it out first, but you always have to write it second. It's negative 4. You see that right there, the y-coordinate. The x-coordinate is 3. And then finally F.
Do a negative 6.
The x-coordinate is 2. And the y-coordinate is negative 6. Hopefully that gives you a sense of at least figuring out the coordinates. Now let's go the other way. Let's start with coordinates and figure out where those points are. So you have this first one. I'll do it lowercase a in parentheses to differentiate it from this uppercase a. So it's at 4, comma 2. X is equal to 4. Y is equal to 2. X is equal to 4. Y is equal to 2. So that's that point right there. Let's do the next one. Let me do it in a color that you'll be able to read.
3 and
B.
5.5.
X is equal to negative 3. X is equal to negative 3. Y is equal to 5.5. So you go all the way up to 5.5. Right? Y is equal to 5.5. So that is the point lowercase b with parentheses around it. Then C. 4, negative 4. X is equal to 4. Y is equal to negative 4. Right over there. And then one last one. I'll do it in orange. D. X is negative 2. Y is negative 3. X is negative 2. Y is negative 3. Right there. That's the D with parentheses. And you could have gone the other way. You could have said, hey, y is equal to negative 3. X is equal to negative 2. So you could go to the left and down, or you could go down and to the left, and you're still going to get to the same point. So hopefully that gives you a good sense of how to figure out coordinates, or if you're given coordinates, how to figure out where to plot something on the xy coordinate plane. Now let's do a slightly more involved problem. So it says the following 3 points are 3 vertices of square ABCD. Plot them on a graph, then determine what the coordinates of the 4th point D would be. All right, let's plot these on a graph as they tell us to do. All right, that'll be my y-axis. That's my y-axis, the vertical axis. That'll be my x-axis. And let me mark it. So that's x equals 1, 2, 3, 4. This is x is equal to negative 1, negative 2, negative 3, negative 4. That's y is equal to 1, 2, 3, 4. This is y is equal to negative 1, negative 2, negative 3, negative 4. I could write that as y equals 4. That's y equals negative 4. X is equal to 4. X is equal to negative 4. And let's see, let's plot these points. So first we have the point A is equal to negative 4, negative 4. So we go x is negative 4, and then y is negative 4. So we drop down 4 right there. And that is our point A. Negative 4, negative 4. And just to familiarize yourself with a labeling scheme that you may or may not have seen before, is that people label these sections of the coordinate plane. They call this the first quadrant. They call this the second quadrant. They call this the third quadrant. And they call this the fourth quadrant. And these are just the Roman numerals for 1, 2, 3, and 4. So this point is in the third quadrant. When we looked up at this stuff over here, these points are in the fourth quadrant. These are in the third, second, first. Just an interesting thing to know. Sometimes someone might ask you, what quadrant is that point in? And you just say, oh, okay, I see. If they're both negative, they're going to be in the third quadrant. If just the y is negative, but the x is positive, you're going to be in the fourth. If they're both positive, you're in the first. If y is positive but x is negative, you're in the second. And we'll talk a little bit about that as we plot these points. So point B, x is positive. It's 1, 2, 3. And y is -4. So we drop down here into the fourth quadrant. That is the point B. It's 3, -4. So we can already see the bottom of our rectangle that they're talking about right there. And notice, both of these have the exact same y. They're both at the same level below the x-axis. And then what's the next point? Point C is 3, 3. So 3, 3. It's in the first quadrant. Both of its coordinates are positive. 3, 3. Both x and y are positive. And notice, it's on the same vertical as B. It has the same x value. They both have an x value of 3. So it's right above it. Right above it. Now we have to figure out the last point here. Well, the point is going to have to be on the same vertical as this point. It's going to have to be on the same vertical as this point, which means it's going to have the same x value as this point. So the x value is going to be -4. And then it's going to have to be on the same horizontal as this point. It's going to have to be on the same horizontal as that point. So it's going to have the same y value. It's at the same height above the x-axis. So it's going to have to be 3. So that is our point D. Notice it's at -4, right above A, and it's at y is equal to 3, right to the left of point C. And we are done.
Oh shit, saw the video.
Plot the ordered pair 6, -8 in the coordinate plane. So this is the coordinate plane right over here. The horizontal axis here, this is the x-axis. The vertical axis here is the y-axis. And the convention when we get a coordinate, when we get an ordered pair like this, is that the first coordinate is the x-coordinate, and the second coordinate is the y-coordinate. So they're telling us that we have an x-coordinate of 6. X-coordinate of 6. That means we count up 6 on the x-axis. So let's count up 1. I can even write down 1. And then we have 2. That's right there. Then we have 3. Then we have 4. Then we have 5. And then we've moved up 6 along the x-axis. We started at the origin at 0, 0. That's the origin. And we moved 6 to the right. That's this part right over here. Now our y-coordinate is -8. That means we move down 8 in the vertical direction. So we can see it right over here. So this right here, I'll just do every 2. So this is down 1. This right here is -2, -3. This right here is -4, -5, -6, -7, -8. So we move to the right 6, and then we move down 8. We move to the right 6, and then we move down 1, 2, 3, 4, 5, 6, 7, and 8. And we are right over there. So that is the point 6, 6, -8. You could also look at it this way. The x-coordinate is 6, so you move 6 there. And so we're going to be along this line right over here. And then you can go, and then the y-coordinate is -8. So you go down to -8, and you say we're going to be along this line over here. And the place that they intersect is this coordinate. The easiest way I'd like to think of it, move 6 to the right, move along the x-axis, and then move along in the vertical direction along the y-axis. So you go down 8.
Oh, so I'm supposed to do this after the corresponding videos, right? Understand? Oh man, it's not. It's different titles. Not the same though. Finding absolute values? Yeah. Let's just watch all the videos first.
Consider the following coordinate pairs, and they give us a bunch right over here. Which of those pairs is not graphed below? So let's see, 3, -2. So 3, -2. Well, actually, that looks like that first one is not graphed. So 3, -2 isn't graphed. And you can verify that all of these others do seem to be graphed. 4, -8 is right there. -8, 3 is right over here. 4, 6. 4, 6 is right there. And -1, 0 is right there. So let's do a couple more of these. So is -5 comma 0 graphed? Yep, it's right over there. -4 comma +5 should be there, so that's not graphed. So we'll just select that one. Let's do one more of these. -8 comma 4. So -8 comma 4. We got lucky. The first one is not graphed. -8 comma 4. And we're done.
Oh, this is really quick. That was really quick. I like it. In this tutorial, we're going to plot, and we'll start in the first quadrant, plotting the point 7, 4. Plotting the point -5. It's the third quadrant, right? -8, 6. So far, I'm going to try to order pair for each point. Wait, what? Oh, okay. So it's gonna be like -4, -3. This one's gonna be 1 and -2.5. I mean, both positive 3 and 1. Check. Okay, cool. Next video. Quadrants of the coordinate plane.
In which quadrant is the point -7, 7 located? So let's just review what a quadrant is. A quadrant are each of the 4 sections of the coordinate plane. And when we talk about the sections, we're talking about the sections as divided by the coordinate axes. So this right here is the x-axis, and this up-down axis is the y-axis. And you can see it divides the coordinate plane into 4 sections. We call each of these sections quadrants. This one over here, where both the x values and the y values are positive, we call the first quadrant. And we use the Roman numeral 1. Then if we kind of move counterclockwise around the coordinate plane, this quadrant, where the x values are negative and the y values are positive, we call this the second quadrant. We call this the second, I could write it. We call this the second quadrant. Second quadrant. Then we go down here where both the x values are negative and the y values are negative. We call this the third quadrant. Once again, using Roman numerals. Then finally, the quadrant where the x values are positive but the y values are negative, we call this the fourth quadrant. So let's see which quadrant the point -7, 7 is located. So there's 2 ways to think about it. You could just say, look, we have a negative x value. Our x value is negative, so we're going to move to the left. So we're going to be on this side. We're going to be on this side right here of the coordinate plane. So we're either, just by the fact that the x value is negative, we're going to be either in the second or the third quadrant. Now, we know that the y value is positive. We know that the y value is positive. So if the x value is negative and the y value is positive, we're going to land someplace right over here in the second quadrant. The other way to think about it is you could literally just plot this point and see that it falls in the second quadrant. So let's do that. If x is -7, so that's -1, -2, -3, -4, -5, -6, -7. Did I do that right? 1, 2, 3, 4, 5, 6, 7. So this is x is -7, and then we have to go up 7 because y is equal to +7. So 1, 2, 3, 4, 5, 6, 7. So the point -7, 7 is right over here, clearly lies in the second quadrant. Plot 4, -1 and select the quadrant in which the point lies. So 4, the first number in our ordered pair, that's our x-coordinate. That says how far to move in the horizontal or the x direction. It's a +4, so I'm going to go 4 to the right. And then the second coordinate says, what do we do in the vertical direction or in the y direction? It's a -1. Since it's negative, we're going to go down. And it's a -1, so we're going to go down 1. So that right over there is the point 4, -1. So I've plotted it, but now I have to select which quadrant the point lies in. And this is just a naming convention. This is the first quadrant, this is the second quadrant, this is the third quadrant, and this is the fourth quadrant. So the point lies in the fourth quadrant, quadrant 4. And I guess you have to know your Roman numerals a little bit to know that that's representing quadrant 4. Let's do a couple more of these. Plot 8,
Same
comma,
shit,
negative
quadrant
4,
four.
and select the quadrant in which the point lies. Well, my x coordinate is 8, so I move 8, or I go 8 in the positive x direction. And then my y coordinate is negative 4, so I go 4 down. And this is sitting again in, not the first, not the second, not the third, but the fourth quadrant, in quadrant 4. Let's do one more of these. Hopefully we get a different quadrant. So we want to plot the point negative 5, comma,
Second
5.
quadrant.
So now my x coordinate is negative. It's negative 5. So I'm going to move to the left in the x direction. So I go to negative 5. And my y coordinate is positive. So I go up 5. So negative 5, comma, 5. And this is sitting not in the first quadrant, but the second quadrant. And of course, this is the third and the fourth. So this is sitting in the second quadrant. Check answer, and we got it right.
And we're done. Coordinate planes show one horizontal axis and the one vertical axis, the y-axis. The origin. Pair, order pair 0, 0, order. The coordinate planes divide the 4 quadrants. Top right, top left forward, bottom left, and right. Where is point A located on? Holy shit. I'm gonna say x-axis. It's not. Oh shit. I'd say x. Okay. Origin. First quadrant. Graphic coordinate reviews. We have 6 and negative 8. We have 2 and 7. 1, negative 4. Which ordered person on the graph below? Okay, let's see. Negative 4, negative 9, positive 9, negative 4. Okay, someone's knocking. Alam mo yung ball cone? Wala sa chicken eh. Mayroon lang eh. Okay. We're back. So 4, negative 9 is plot, 9, 4 is plot, negative 9 and positive 4 is not. Oh my god.
Ayaw mo? May agad di ako dun. Oh? Ano yun mo? Ayaw, hindi ko pa naman nakakapos. Parisip ka naman dun. Saan yung bilili? Sa Jollibee, yung marinated.
Wow.
Labarisa ng...
Diyan, mamaya nagkakaroon ko kayo dyan.
Hindi na mo nabili yan. Wala, parang lang. May go-occurrence ka pala eh.
7-Eleven ko na nabili.
Kaso maliit ka na.
Bumili ako 4 na pack nun.
Apat? Wala ka ng gatas, kulang mo.
Ano ka nang bilhin lang ito bukas?
Okay.
Pero thank you lang, kaso may agad yan ngayon.
Chichiri mo ko.
ng pito dan?
Black pa?
Kahit ano. Okay, very much.
Malena's town is built on a grid similar to the coordinate plane. She is riding her bicycle from her home at point -3, 4 to the mall at point -3, -7. Each unit on the graph denotes one city block. Plot the 2 points and find the distance between Malena's home and the mall. So let's see, they tell her she's riding her bicycle from her home at the point -3, 4. So let's plot -3, 4. So now I'll use this point right over here. So -3 is our x coordinate. So we're going to go 3 to the left of the origin. 1, 2, 3. That gets us to -3. And +4 is our y coordinate. So we're going to go 4 above the origin. Or I should say we're going to go 4 up. So we're going to go 4 up. So we went -3, or we went 3 to the left. That's -3. +4. Or you could say we went +4, -3. This tells us what we do in the horizontal direction. This tells us what we do in the vertical direction. Now let's figure out, that's where her home is. Now let's figure out where the mall is. It's at the point -3, -7. So -3, we went -3 along the horizontal direction, and then -7 along the vertical direction. So we get to -3, -7 right over there. Now we need to figure out the distance between her home and the mall. And we could actually count it out.
Kunin ko pala yung 4,000. Oh! Busy si Kuya Christian. Hindi ko 4,000. Bumili ang pagkain niya. 3,500 na tayo. Okay. Bukas ko lang gawin ng
it out, or we could just compute it. If we wanted to count it out, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 blocks. So we could type that in. And another way to think about it is they have the exact same x-axis, the exact same x-coordinate. They're both at the x-coordinate -3. The only difference between these two is what is happening in the y-coordinate. This is at a +4, this is at a -7. +4, -7. So we're really trying to find the distance between 4 and -7. So if I were to say 4 minus -7, we would get this distance right over here. So we have 4 minus -7, which is the same thing as 4 plus 7, which is 11. Let's do a couple more. Carlos is hanging a poster in the area shown by the red rectangle. He is placing a nail in the center of the blue line. In the second graph, plot the point where he places the nail. So he wants to place a nail in the center of the blue line. So the center of the blue line is 6 units long. The center is right over here. That's 3 to the right, 3 to the left. So he wants to put the nail at the point x equals 0, y is equal to 4. So he wants to put it at x is equal to 0, y is equal to 4. That's this point right over here. So let's check our answer. Let's do one more. Town A and Town B are connected by a train that has a station at the point -1, 3. I see that. The train tracks are in blue. Fair enough. Which town is closer to the station along the train route? Town A or Town B? So they're not just asking us what's the kind of crow's flight, the distance that if you were to fly. They're saying the distance, which town is closer to the station along the train route. So if you were to follow the train route just like that. So the A right over here, you have to go, if you were going along the train route, you would have to go 1, 2, 3, 4, 5, 6 in the x direction, and then 1, 2, 3, 4, 5 along the y direction. So you'd have to go a total of 11. If you're going from B, you're going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 along the x direction, and then 1, 2, 3, 4, 5, 6. So 6 along the vertical direction. So you're going to go total 17. So it's pretty close. It's pretty obvious that A is closer along the tracks. Now, you could also think about it in terms of coordinates, because A is at the coordinate -7, 8. And if you were to think about -7, 8, to get from -7 to -1 along the x-coordinates, you're going to go 6. And then to go from 8 to 3, you're going to go 5 more. So you can also not necessarily count it out. You can actually just think about the coordinates. But either way, you see that town A is closer. The point -8, 5 is reflected across the y-axis. Plot -8, 5 and its reflection across the y-axis. So first let's plot -8, 5. So its x-coordinate is -8. So I'll just use this one right over here. So the x-coordinate is -8. And the y-coordinate is 5. So I'll go up 5. So the y-coordinate is 5 right over here. You see -8 and 5. We've gone 8 to the left because it's negative. And then we've gone 5 up because it's a positive 5. So we've plotted -8, 5. Now we have to plot its reflection across the y-axis. The y-axis. And so you can imagine if this was some type of lake or something, and you were to see its reflection, and this is, say, like the moon, you would see its reflection roughly around here. You would see it an equal distance away from the y-axis. So you would see it at 8 to the right of the y-axis, which would be at +8, and still 5 above the x-axis. So that's its reflection right over here. Its reflection is the point 8, 5. Let's do a couple more of these. The point -6, -7 is reflected across the x-axis. Plot -6, -7 and its reflection across the x-axis. So -6, -7. So we're going to go 6 to the left of the origin, and we're going to go 6 below, and we're going to go down 7. So there we go. -6, -7 is right there. And we are reflecting across the x-axis. So once again, if you imagine that this is some type of a lake, or maybe some type of an upside down lake or a mirror, where would we think we see its reflection? Well, its reflection would be the same distance. We're reflecting across the x-axis. So it would be the same distance, but now above the x-axis. So this was 7 below. Now we're going to go 7 above the x-axis, and it's going to be at the same x-coordinate. So there you have it right over here. We reflected this point to right up here because we reflected across the x-axis. Let's check our answer. Let's do one more. The point B is a reflection of point A across which axis? So let's think about this right over here. This is at the point -6, 5. This is at the point -5, 6. So let's see. It doesn't look like it's only one axis. If I were to reflect this point across the y-axis, it would go all the way to +6, 5. So it would go all the way right over here. So if I reflect A just across the y-axis, it would go there. And then if I reflected that point across the x-axis, then I would end up at 5 below the x-axis at an x-coordinate of 6. So to go from A to B, you could reflect across the y and then the x, or you could reflect across the x. It would get you right over here. It would get you to -6, 5, and then reflect across the y. So it's really reflecting across both axes. So we would reflect across the x-axis and then the y-axis. It would have also been legitimate if we said the y-axis and then the x-axis. Let's check our answer. We got it right.
Few more videos.
The following table contains the first 5 terms of given pattern A. Generate pattern B according to this rule. For every term of pattern A, so they give us the terms of pattern A here, multiply the term by 3 and add 1 to get the corresponding term of pattern B. Then graph the pairs of corresponding terms. So for every term in pattern A, we want to multiply by 3 and add 1. So if we multiply 0 by 3, we get 0, and you add 1, you get 1. You multiply 1 by 3, you get 3, and then you add 1, you get 4. 2 times 3 is 6, plus 1 is 7. 3 times 3 is 9,
Plus 10.
plus 1 is 10. Remember, we're just multiplying by 3 and adding 1. 4 times 3 is 12, plus 1 is 13. So those are the corresponding terms for pattern B. And then they ask us to graph them. So let's try to graph these points. Let's try to graph these points. So when pattern A is 0, pattern B is 1. When pattern A is 0, so this is pattern A equaling 0, that's our horizontal axis, the value of pattern A. Pattern B is the value of our vertical axis. Pattern B is 1. When pattern A is 1, pattern B is 4. So it's 1, 4. So when pattern A is 1, pattern B is 4. Pattern B is on the vertical axis. When pattern A is 2, pattern B is 7. So 2 and 7. When pattern A is 3, pattern B is 10. So 3, 10. So 3 in the horizontal direction, that's our pattern A value, and our pattern B value is 10. And then finally, when pattern A is 4, pattern B is 13. Pattern B is 13. Now let's just look at these patterns. We see pattern A is increasing by 1 each time, while pattern B is increasing by pattern A starts at 0 and increases by 1, while pattern B starts at 1 and increases by 3, which makes complete sense. It makes sense that it starts at 1 because all of these you multiply by 3 and add 1. So you start at 1, and then the fact that we're multiplying by 3, that's what's leading to the distance between these points being 3. So let's check our answer, make sure we got this right, and we did. The following graph represents the first 5 terms of 2 given patterns. In the answer box, there are different statements about the 2 patterns. Choose all correct statements. So here for each point, this point right over here, this represents its horizontal coordinate is the first term of pattern A, which is 4, and its vertical coordinate is the first term in pattern B, which is 1. And then we can do that for the other points as well. So actually, let's figure out what the values are. So we have pattern A, and then we have pattern B. So the first term for pattern A is 4. And when pattern A is 4, the first term for pattern B is 1. The second term for pattern A is 7. And when pattern A is 7, pattern B is also 7. Third term, pattern A is 10, and pattern B is 13.
A is like
And then fourth term, pattern A is 13. And pattern B is 19. And then finally, fifth term, pattern A is 16, and pattern B is 25. Now before even looking at these, let's see what we can think about these patterns here. So it looks like pattern A starts at 4, and it increases by 3 every time. To go from one term to the next, you just have to add 3. Now what about for pattern B? Well, pattern B starts at 1,
6.
and every term here, it looks like you're adding 6. So when pattern A increases by 3, and we're moving in the horizontal direction, based on the fact that pattern A is represented on the horizontal axis, we're going to move up 6 in the vertical axis, and we see that here. Pattern A increases by 3. Pattern A increases by 3 from one term to the next. And when that increased by 3, pattern B increased by 6 from one term to the next. Pattern B increased by 6 from one term to the next. And we see that it keeps doing that. Now let's think about what we have over here to see which of these statements actually apply to this. For every term in pattern A, multiply the term by 2 and then subtract 7 to get the corresponding term from pattern B. So let's see if that holds up. So according to this, if this was true, I should be able to take this, multiply by 2, and subtract 7 and get that. So let's see. Is 1 equal to 2 times 8 minus 7? Or sorry, 2 times 4 minus 7. So 2 times this number, 2 times 4 minus 7. Well, 8 minus 7 is equal to 1. Is this right over here equal to 2 times this 7 minus 7? Well, yeah, it's equal to 7. Is 13 equal to 2 times 10? 2 times 10 minus 7. Yeah, 20 minus 7 is 13. is 19, equal to 2 times 13 minus 7. 26 minus 7 is 19. Is 25 equal to 2 times 16 minus 7? Well, 32 minus 7 is 25. So this first statement checks out. For the corresponding term, the value of pattern B is 2 times the value of pattern A minus 7. Now let's look at the second one. The terms of pattern B are always greater than or equal to their corresponding terms from pattern A. Well, no, that's not right. It's true for a couple of scenarios. Here, for the third, fourth, and fifth term, or actually for the second, third, fourth, and fifth terms, pattern B is equal to or greater than pattern A. But for the first term, it's not true. Pattern A is greater. So this is not right. To get from each point to the next, you need to move 3 units to the right and 6 units up. Well, that's exactly what we talked about. From one term to the next, pattern A, along our horizontal axis, we increase by 3, while pattern B, we increase, which is plotted on our vertical axis, by 6. So you move 3 to the right and 6 up. So that is right. The second terms of both patterns are 7. Well, yeah, we see that right over here. The second terms are 7. We have 7 here, and we have 7 there. And so that is right as well. So the only one that doesn't apply is this second one. This is not right.
The last one.
Below are ordered pairs that represent the first 6 terms of 2 given patterns. The first value in each pair is a term from pattern A, and the second value is a term from pattern B. In the answer box, there are different statements about the 2 patterns. Choose all correct statements. So let's think about what's going on here. They said the first term is pattern A. So pattern A, the first term in each of these coordinates is pattern A, or in each pair is pattern A. So pattern A goes from 1 to 2 to 4 to 8 to 16 to 32. So it looks like pattern A, to go from the first term to the second term, we multiplied by 2. We multiplied by 2, and then go from the second to the third term, we also multiplied by 2, and we just keep multiplying by 2. Multiply by 2, and we just keep doing that. 8 times 2 is 16. 16 times 2 is 32. Now let's think about what's going on with pattern B. Pattern B. So pattern B is the second number in each of these pairs, and it's just always 3. So there's a couple of ways you think about it. You could just say pattern B is always 3. You could say pattern B starts at 3 and we're just adding 0 every time. Or you could say that pattern B starts at 3 and we are multiplying by 1 every time. Either of those would give you just 3 showing up over and over again. Over and over again. So now that we've looked at these pairs, which show the corresponding terms for pattern A and pattern B, let's look at the choices here and see which of these apply. In pattern A, you can get from any term to the next by multiplying by a constant number. Well, that looks right. We go from the first term to the second term by multiplying by 2. Then we multiply by 2 again to get to the third term. Then we keep multiplying by 2. So that constant number that we're multiplying by to get to the next term is 2. So this looks right. The next pair should be 52, 3. So let's think about this. If we keep doubling for pattern A, so this is going to be times 2. 32 times 2 is 64. And then if we say that this is 1 times the previous term, we're just going to get a 3 again. So it should be 64, 3 should be the next one. They say the next pair should be 52, 3. So that's not right. If we graph the pairs, the points will be on the same line. So let's think about that a little bit. Let's think about that. So this is my vertical axis.
Yeah,
this is my horizontal axis. On the horizontal axis, I will graph pattern A. And on my vertical axis, I will graph pattern B. Pattern B. And let's see, pattern A goes all the way up to 32. So I'm going to try my best here. So let's say that this is 32. Then half of that is going to be 16. Half of that is going to be 8. Half of that is going to be 4. Half of that is going to be 2. And half of that is going to be 1. So these are all the points on pattern A. But for any of them, the corresponding term on pattern B is 3. So we have when pattern A is 1, pattern B is 3. 1, 3. When pattern A is 2, pattern B is 3. When pattern A is 4, pattern B is 3. When pattern A is 8, pattern B is 3. When pattern 8 is 16, this is like a tongue. When pattern A is 16, pattern B is 3. When pattern A is 32, pattern B is 3. And you see, they all sit on a line. They all sit on the line. They all sit on this horizontal line, or at least the way that we've drawn it. They all sit on this line that you probably can't see in yellow. So let me do it in this red color. They all sit on this line right over here. So this looks right. If we graph the pairs, the points will be on the same line. So I'll go with that one. In pattern B, you can get from any term to the next by multiplying by a constant number. Well, yeah, even though every term is the same term, but you can get from a 3 to a 3 by always multiplying by 1. 1 is a constant number, so we're just multiplying every term by 1. So that also seems to be right. So all of these are right except the second one. The next pair isn't 52, 3. It's going to be 64, 3.
Oh yeah, it's a lot of activities doing this. Okay, let's go. Let's not make a mistake. Which ordered pair is not graphed below? Let's see, -3 and -8. Okay, cool. 3, -8. -3 and +8. Drag the dots to plot. 6, -8. 2, +7. 1, -4. This is like quite the same from the article, right? Right. Hexagon 6, 8, and 2, +7. Oh shit, so +1. +1, -4. Now use the following coordinate plane to write the ordered pair up for each one. A is gonna be 4, 0. Oh my god. B is 0, -4.5, I guess. And then C is gonna be -2 and +2. Which point for which point is the y coordinate less than 1.5? For which point is the y coordinate less than -1.5? It's in D and B. D and B. Which ordered pair is not graphed below? Okay, +2, -2, -2, 0. 0, -2, so -2, -2. Drag the dots to plot. Oh shit. Okay. 7.5 and -2. So you have -3 and +7. 7, and we have 2, 0. To write the ordered pair for each point. A is -3, -1. B is +3, -1, and C is what's this? -3, -1, +3. Let's double check. Could be wrong. -3, -1, +3, -1, and then we have -1 and +3. Quadrants in the coordinate plane. Where is the coordinate? Third quadrant. Oh, I have to grab as well. Okay, -5, -9. 5, -9. Point is y coordinate 0, but its coordinate is not 0. What? Point. Oh, okay. Y coordinate is 0, but its coordinate is not 0. It's an x-axis. Oh my gosh, this is hard. Quadrant 1, 4, 3. Yeah. Drag the plot 0 and select selection of origin plane. 0 and -4. It's in the y-axis. Give the location of point P on the coordinate plane. The value of A is positive. So it could be at quadrant 1, could quadrant 4, and could be at x-axis. Select the quadrant or axis where each ordered pair is located on the coordinate plane. -5, positive 7 is probably true. Positive -4, 0, 5 is in the y-axis. Drag the dot plot -1, positive 5. It's in the second quadrant. Gosh, there's a lot. Oh my god, it's insane. What is located 3 units from point M? Okay, point M is located 0, -5, B. Point S is located at 9, -3. Point S to point T. It's in 13. Yo, what? Oh my god, you made a mistake. What? Point is located at 9. Oh fuck. This is, both are positive, so it should be 5. Oh my god, I was thinking the other one's negative. Plot the points -3 in the coordinate plane below. God damn it. Now I'm not in the mood again. 6, 4. Uh, 6, 49. Plot the 2 points that are 3 units from, and also share the same y coordinate as point C. Wait, what? They're the same true. Oh, okay. Same y, so it's gonna be like this one, and then 1, 2, 3, 1, 2, 1, 2, 3, 1, 2. No, chill. 1, 2, 3, 1, 2, 3. Okay. Point M is located 9, 0. What is located 4 units from M? That's A. Point W is located at -5, -3. Check all of the following that are 5 units from point W. Okay. It's 5 away. And no. 3 and 2. Okay. Whoa, just A? One, 2, 3, and oh fuck, it's actual 6. Okay, cool. I accept my defeat. I will have to redo the whole thing. Plot the points -6, +8. -6, -3. Okay, let's. Oh shit. That's gonna be hard. Plot 2 points that are 6 units from point B and also share the same. Okay, it's gonna be at 7. Same y coordinate, right? So 6, 1, 5, 5. 1, 2, 3, 4, 5, 6. 1, 2, 1, 2, 3, 4, 5, 6. Pretty sure it's correct. 4, negative 2. Let's gonna see. Oh shit, wait, what? Good. 4, negative 2. 1, 2. What is located 2 units? Ah, it's x-axis. Point H is located at 2, 7. Select all of the following are 7 units from point H. Okay, let's see. This is what? Okay, this is pretty hard. Okay, let's see. This is not it. This is just. Oh, it could be 5 to 7. And then what is this? I think this is too much. 7 and then negative 7. No. X-axis. No, it's A. Let's see. 2. Oh, actually, yeah. Oh my god. Oh yeah, it's good. What? Plot the points negative 8 and positive 7. Negative 8, positive 7, and positive 5, positive 7. 7, 5, 8. Okay, let's see for 7, right? Both 7. Okay, one's negative 8 and the other's positive 5. What's the distance between these 2 points? Plot the points that are 7 units from point C. And also share the same y coordinate as point C. Let's see. 1 is gonna be 8. Gonna be 5. Shall 6. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 6. 8, 6. Yeah, much. Let's get on negative 7, 0. What is located 6 units from M? 1, C. Point Q is located negative 4, positive 6. R is located at 8 and 6. What is the distance from point Q to R? 6, 6, 4, 12. Well, let's see. 6, 6, right? Okay. So it's real close. Okay, cool. Start. Coordinate plane problems in all 4 quadrants. Everett graphs the number of yards the tiger traveled in the first 7 plays of the football game. How many yards did the tiger travel on the 6th play of the game? Wait, what? The number of yards that the tigers traveled in the first 7 plays of the game. How am I supposed to know if which is first? I mean, this could be first, I don't know. How many yards did the tigers travel on the 6th play of the game? Is it referring to this guy? 1, 2, 3, 4, 5, 6. Oh, of course, play. And then yards. Play 6. It's 9 yards. Okay, cool. X is play. And our 6th play, we get 9 yards. Okay. Alan graphed the relation between terminal elevation for several cities. The x coordinate is the elevation in meters, and the y coordinate is the temperature C. A city 6 above sea level is 9 below. I think it should be quadrant 4, right? X coordinate is elevation above, and Y coordinate is temperature below now. Quadrant 4. Aditya installed solar panels for her house, and the solar panels produce more than net electricity is net electricity is negative. The graph below shows that days in July and in kilowatts. If each statement is true about the graph, okay. The highest net electricity occurred on 4th of July. 4th. Okay, it's true. The net electricity used on 2nd July is represented by 2 negative. No! In the coordinate plane below, the x-axis represents the number of hours before or afternoon. For example, negative 11 a.m. Oh, cool. The y-axis represents temperature in degrees Celsius. Represents 2 temperatures different times of day. Wow, cool. How many hours pass between the two temperatures shown? Below. 10 hours, I guess. Oh shit. I'm supposed to grab. Am I supposed to say this is negative 1, negative 6? A negative 1 and positive 6? And 7, positive 6? The points negative 1 and positive 6 and 7 and 6 are shown below. It's 8. Yeah. The photograph show the relation between the level in C and their cats change in weight over the last 10 days. What is the meaning of point A? Here we go, point A. Negative 9 and negative. Drop at below negative and lost. C in 2. Wait. Below. No, we're not gaining. They're both. Point A is both below and lost. Yeah. Jerome graphed the relation between the temperature and the change in the number of people in sledding park. Sledding. Which quadrant can contain a point showing a decrease in number of people sled? Wait, what? C. People who are sledding. Oh, decrease in number of sledding. Oh, it's gonna be 2 and 3. Oh, actually no. Actually 3 and 4. The X is the temperature and the Y is the change in the number of people who are sledding. Paulo tracks his commute time. The coordinate plane below shows some of his commute times in the last 2 weeks. The x-axis of the graph represents the number of days before today. For example, yesterday, commute times in minutes. 2 days ago, Paulo commute time was halfway between his commute times 8 and 9 days ago. 2 days ago. Doesn't even show here. The fuck? At what coordinate should Paulo graph in his commute 2 days ago? Okay, negative 2 and halfway between 8 and 8. So 2 and 9 days ago. 9 days ago was 18. 8 and 9. Halfway between 24 and 18. Holy shit, what's the half of that? By sis. By 3? I mean 8 plus 6 times 4. So I guess by 3. So actually it's 21. Okay, let's do this again. It's the last question, right? 2 days ago, Paolo commute time was halfway between his commute times 8 and 9 days ago. This is 9 days ago, this is 8 days ago. And 4 and 18. So halfway of that would be 23. No, not really, 21. So negative 2, 21. Nice. Nice. Oh my god, there's a lot of practice. 5 more, and then a quiz, and then a unit test. This is insane. How many hours am I in? Okay. Holy shit, time flies. Oh my god, it's already 1. What the fuck? The point B is a reflection of point A on which axis? Okay, 5. This is 6, and then this is 6 as well. That's 5, negative 5. The point is coordinate to what point do we get when we reflect A across the y-axis? A across the y-axis, you get E. Drag the dot to plot the reflection of A across the y-axis. A across the y. 1, 2, 3, right? So 1, 2, 3. 3 points. The point B is a reflection of point A across which axis? Okay, this is 8. So this should be 8 as well. And this is 7, should be 7 as well. Okay. Okay. Table from rules that relate to variables. A rule for creating a pattern is given below. The rule begins with a number called the input and creates a number called the output. Multiply the input by 5, then subtract 4 from the result to get the output. Which input and output works for the rule? Okay. Multiply the input by 5, it's going to be 10 minus 4, it's 2. No. Minus 4, it's 6. If you multiply this 5, you get 15. It's 11. 25. Or for getting a pattern is given below. Multiply x by 0.5 to get y. Which ordered pair works for the rule? Multiply x by 5 to get y. Add 12 to x. Add 12 to x to get y. For both rules. Okay. So multiply x by 5. Add 12 to get y. No. Wait, this works. A table is made using the following 2 patterns. Add by 8. That's gonna be 20, right? The 28. Divide by 2. Rule 1, subtract 8 from the input to get the output. Divide the input by 3 to get the output. For both rules. Okay. Subtract 8 from the output, it's going to be 10. So that's not work. Subtract 8 is going to be 4. Divide by 3 is going to be 4. Y is 2 more than 4 times x. Okay, let's see. Y is 2 more than 4 times x. 0 times 4 plus 2. 4 times 8 plus 2. 16 plus 2. Okay. A rule for creating values given below. The rule begins with okay. Multiply the input by 6 to get the output. Which input and output table works for the rule? Multiply the input by 6. Okay. The rules that relate to variables. Okay. Add 10 to the input to get the output. No? Yeah. Add 5 to the input to get the output. No. Multiply the input by 4. No. By 3. And add 3. Yeah. Divide x by 3 to get 1. No? Subtract 4. Yeah, subtract 4. Subtract 2. No. Okay, this one. Multiply 8 by 2. You have 8 minus 6 is 2. 2 minus 6, 4. Yeah, 12. Okay. For any point on line C, the coordinate y is wait, what is this? For any point on line C, oh, there it is. C. The y coordinate is 3. Uh, 2, and then we have 5, we have 4, we have 4, 4, and then 8, 2. Line N, the y is 6. In the following graph, the ordered pairs from the table represents on line M. Okay, 1, 2, 4, 4, 5, and I guess this is 6, 7. 6. It's linear stuff. The following rules, do you want to say the x and y? Subtract 2 from x to get y. Subtract 2 from x to get y. Okay. Next, plot the ordered pair from. Okay. So we have 8 and 6, and we have 6 and 4. We have 4 and 2. Let's see. 8, 6, 6, 4, and 4, 2. The problem is to find y, multiply x by 2, then subtract 1. We have 1, and then this x gonna be 5, 9. Yep. 1, 1. You have 3, 5, and 5, 9. Cool. Ace actual works. X and Y. Oh, okay. Y 3 and 2, 6, and I guess 3, 9. multiply x by 3. Multiply x by 4 to get y. 0. 4, 8. Multiply x by 4, right? Okay. Then we have 0, 4, 2, 8. 0, 0, 1, 4, 2, 8. Gosh, I'm so close. 2 patterns. A table is made using the following 2 patterns. The terms in pattern Y are 2 times the term of x. Yeah? Add 4, 12, 16. Start to add 1, 3, 4. Okay, it's divided by 4. The table is made using the following patterns. X starts 3, add 4. 7, 11. Starting rule 9, add 4, add 13, 17. It's correct. P plus 4, 7 plus 4, 11. P plus 4, 13 plus 4, 7. Yeah. Oh my gosh, what is this? Pattern Y are 3 times greater than in pattern X. Not really. What the fuck? I think there's something wrong. Add 4. 4, 11. Add 4. 9. Pattern Y. Add 4. So I have 9. Then add 4. 13. Right? 3 times greater. What the fuck? This doesn't have any valid solution. Fuck. Yo, this is insane. What the fuck? What is even this shit? Pattern X starting number 3. Rule add 4. So we have 4, 7, add 4, 11. Pattern Y starting number 9. Rule add 4. With 9, 10, 11, 12, 13, right? Just 14, 17. The terms in pattern Y are 3 times greater. I mean, it applies for the first one, 3 times greater. But this... What the fuck? Oh my god. You're so weird. What? What? Oh, 6 greater. Oh my god, I thought it was times 6 times, but it's just constant 6. Oh my god. Okay, cool. My reading comprehension sucks ass. 4, 5. Okay. Plot the ordered pairs x and we have 9, 3. We have 12, 4. We have 15, 15, 5. 15, 5. Oh, okay. Gosh, my reading comprehension sucks. Okay, cool, whatever. Add 1, add 5, 2, 5 times. Rule add 5, we have 10. 15, 2, 3 again. The terms of pattern y are 1/5. Subtract 7. Oh my god, how do I subtract 7 from this? It's 25, right? And then 18. Subtract 7 as well? Okay, cool. Oh my god, subtract. It's gonna be like, what is this? 27? Yeah, of course, it's 27. The terms in pattern y are 2. Yeah. Add 3, 6, 9. Add 6, 12, 18. And then plot. Okay, so we have 3 and 6. And we have 6 and 12. Then we have 12 and 18. This looks so weird, should be 9. 9, 18, 3, 6, 6, 12, 9, 18. Cool. Oh yeah. To the quiz, let's not fuck things up. 9 questions. A rule for creating pattern is given below. Subtract 7. Subtract 7 from x to get y. Okay, subtract 7 from x to get y. So we have 7 difference. Now this works. Point E as a positive y coordinate. Where could E be located on coordinate plane? Could be at quadrant 2, 1, and y axis. Ordered is part of which line? 2, 4, J. Plot the points 2, 4. Positive 2 and 4. 2 and negative 8. I guess the distance. This is 2, 4 and 2, negative 8. Distance between 2 points with 12. What point? The point A is coordinate 6, 0. What point do we get when we reflect A across the y axis and then across the x axis? I mean, the x pretty much the same, 0, so we get C. To find y, add 3 to x. 4, 7, 8. Oh shit, 3, right? Not 4. Okay. Let's see again. Find y, add 3. Plus 3, 4, plus 3, 6, plus 3 is 8. So you have 1, 4, 1, 4, 3, 6, and 5, 8. Cool. This is 1, 3. No. A table is made using the following two patterns. Starting number rule, add 1. 8, 9. Add 2, 16, 18. Okay, it's 2 times. let's see. Yeah, cool. 2, what's the difference? 9. Add 9 to the input to get to the output, right? Dexter plans and records his spending. In the coordinate plane below, the x-axis represents the number of days before after day. The point -5 and 8, -5, 8, and 2 and 8, -5, 8, -2, 8 represents planned spending on 2 separate days. Plan to you what? You plan in negative days? How many days separates the 2 days? How many days separate the 2 days Dexter planned to spend $8? What? I guess this is asking for a distance, right? So I'm gonna guess 7. How many days separate the 2 days Dexter planned to spend 8? You had 7. Okay, cool. Let's do the master now, the unit test. Let's go. Move the dot to 12 on the number line. 3, 6, 9, 12. Run the questions. Okay. A table is made using the following 2 patterns. Starting number, add 6, 9, 15, and then add 2, 3, and 5. The terms in y are actually 1/3 times the pattern in x. Which expression is equivalent to -7? Okay, so this is -7 plus 2.5, right? 2.5, yeah, cool. Cool. Just one answer. In the following graph, the ordered person represents point on line M. Complete the missing values in the table. Oh, okay. 1, 9, then we get 4, 6. I guess it's 3, 70. Cool, yeah, it's linear, so it's gonna be 3. Fill in the blanks. They are equal to an absolute value, dudes. Plot 2 points that are 7 units from point D. Also share the same x coordinates point D. Okay, it's gonna be like here about that guy. Same x coordinate and but 7 away units. Be like 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Right. Cool. Same x coordinate. Yeah. Okay. List the greatest. Yeah. Lowest number on the left. 85, 61, 14. Okay. Okay. It's gonna be 63, right? The sun is v kilometers from the upper edge of the Earth's kilometers. The sun is kilometers from the upper edge. Oh my god, this could be wrong, but I don't know. This is the formula for the distance between 2 points, so yeah. Which rule describes the relation between input and this adds 6. This adds 8. This isn't adding 9. 8. Okay, multiply by 2 and then add 1. Okay, multiply by 2 then add 1. Okay, 10. Yeah, cool. Drag the dot to plot the reflection of A across the x-axis. Okay, you're gonna be here, bro. -2 actually. 1, 2, and 1, 2. X-axis. Cool. Sarah graphs the number of yards the Panthers travel in the first 7 plays of the football game. What is the meaning of point A? First 7 plays. Point A. Where are you? Point A. On the third day, you get -3 yards. On the third day, lost. Yeah, that's right, right? Gain. No, lost. It's third day. Point A. Third day. Lost. Yeah, okay, cool. What is the sign of A times B? It's gonna be positive. A is negative, B is positive, and it's multiplied to get positive, bro. Select the quadrant of each ordered pair in for each coordinate plane. Okay, 2, 4 is in first quadrant. It's gonna be third quadrant. Actually no, it's gonna be y-axis. -1 and then positive in second quadrant. It's gonna do. Geographers use negative numbers to represent points below sea level. And positive above sea level. For example, the lowest point in Minnesota is 7.3 meters and the highest point is 14.2. What does 0 meters represent? It's the sea level. The points on the following graph shows the relationship between x and y. For complete the table. Okay, let's complete the table. Let's see, x is 3 and we got 2 for y and 5 for x, and then we get like 6. I guess this is 10, 7, 10. Yeah, cool. Let's verify. 3, 2, 5, 6, and then 7, 10. Okay, which row is going to multiply x by 2, then subtract 4. 6 minus 4, 2. 10 minus 4, 14 minus 4, okay, 8. Evaluate -2 plus 2 minus 2. Wow, I think this is just gonna be 0. Yeah, let's see again, just for safe measurements. A -2 plus 4 is gonna be positive 2 minus 2. Subtract. Oh my gosh, it's gonna be 5, right? Two rules for creating the pattern are given below. Divide x by 4 to get to y. Subtract 18 from x to get to y. Which ordered pair works for both rules? Okay. Divided by 4 you get 6. Subtract 18 from that, you get 6 as well. Cool, that works. And divided by 4, it's not 12, dude. Okay. If I deduct 18 from this, you're not gonna get 8. Oh yeah, mastered. No, so good. Feels good, man. It feels good. Oh yeah, mastered 2 shits in one go. Mastered negative numbers in coordinate plane, and also the measurements. Yeah, this one, and then this one. So the next section is gonna be this guy. I guess this is gonna take me 2 days. 2 days as well. And okay, it's gonna take me a week, I guess, to complete this all. Then the master challenge. I hate. Oh crap. Okay, cool. 63%. Cool. Points. Then 56 now. Where was that before? It's the same 56. 63. Missions. 21%. Okay, I guess that's it. That's it for today. 21% World of Math, 63% Pre-algebra. Part 14 this is, I think. Okay, bye.